Hello everyone, good morning. Good morning. So this is lecture number 5 of ODE. So if you haven't watched the previous classes, go through all the videos because this is a continuation of all the classes, right? Okay. Uh, so far what we are doing in ODE is that we have been solving a differential equations of first order and first degree, right? I have given you there are many methods to solve a differential equations of first order and first degree. The first method is variable separable method that we have completed, and second is equation reducible to the form in which the variables are separated. This second method that is also we have completed. Now we are in third method, which is called homogeneous differential equations, right? This is part 2 of homogeneous differential equation. The previous class itself I have given you what is meant by homogeneous differential equations, right? Um, then we have solved 10 problems based on homogeneous differential equation in the last class, right? So you can see we have introduced what is meant by homogeneous function, right? First, in the previous class, we have introduced what is meant by homogeneous function. After that, I have given you the definition of homogeneous differential equation, right? Is a differential equation in x and y is said to be homogeneous if it can be put in the form dy by dx is equal to f1 of x comma y divided by f2 of x comma y, where f1 and f2 both are homogeneous functions of same degree, right? This is what we discussed in the previous class. If it can be put in this form, then you have to follow these 4 procedures. Put y is equal to vx, so differentiate with respect to x, so you will have dy by dx is equal to v plus x into dv by dx. Now substitute the value of y and dy by dx in this equation and separate the variable. You will have functions of v and dv to one side. You will have functions of functions of x and dx to other side. Separate the variable and integrate. After that, replace v by y by x to get the required solution. This is what we have discussed in the previous class. We have solved almost 10 problem, right? We have solved almost 10 problem in the previous class, right? Yes. So we will start with the 11th problem, right? So in this class, we will be completing this topic, which is homogeneous differential equation. And in the next class, we'll be moving on to equation reducible to homogeneous differential equation, right? So we'll start with 11th problem. So solve x square dy by dx is equal to y into x plus y by 2. Right? This is the continuation of previous class. So we have already completed 10 problems in the previous class. So we are just continuing, right? So first, we will write dy by dx equal to f1 of x comma y by f2 of x comma y, and we will see whether both are homogeneous functions of same degree. If yes, you can write put y is equal to vx and so on, right? Same as dy by dx is equal to y into x plus y divided by 2 times x square, right? You can see both are homogeneous functions of degree 2, right? For example, if we have f1 of x comma y is equal to y into x plus y, so what about f1 of tx comma ty? So it will be ty comma tx plus ty. If we take this t outside, we will have t square y into x plus y, which is t square into f1 of x comma y. So this is a homogeneous function of degree 2, right? This is homogeneous function of degree 2. This is also homogeneous function of degree 2, right? That means both are homogeneous function of degree 2. So this is homogeneous differential equation. So we can make use of substitution. Put y is equal to vx. So differentiate with respect to x. So we will have dy by dx is equal to v plus x into dv by dx. Substitute the value of y and dy by dx. Substitute y and dy by dx value, right? In equation number 1, what is 1? 1 is the given question, which is dy by dx is equal to y into x plus y divided by 2x square. Now what is dy by dx? It is v plus x into dv by dx is equal to y is vx, right? It's a substitution we are making. So y is vx, vx x plus vx divided by 2x square. So this x will get cancelled, right? If I take x outside, we will have x square will get cancelled. So we will have v into 1 plus v divided by 2, right? V into 1 plus v divided by 2. We have v plus x into dv by dx is equal to v into 1 plus v by 2. So if we bring this from that side, we will have v minus v into 1 plus v by 2 is equal to minus x into dv by dx. So we cross multiply this, we will have 2v minus v, 2v minus v minus b square divided by 2 is equal to minus x into dv by dx, right? 2v minus v minus b square. So 2v minus v is v. So we will have v minus b square by 2. V minus b square by 2 is equal to minus x into dv by dx. So we cross multiply this, we will have v minus b square into dx minus 2x dv, right? So we will separate v's and dv's to other side, x and dx to other side. So dv, right? So here we have dv. So dv divided by v minus b square is equal to, here we will have minus 2, right? So we will keep this minus 2 here itself. Okay, so dv by v minus v square, and here we will have minus 1 by 2 dx by x, right? Minus 1 by 2 dx by x, or you can also have 2 here also, right? 2 into dv. You can also write, you can also keep 2 here also, right? 2 into v minus b square. Let us keep this 2 here. Right? 2 dv, this, right? So you can see the variables are separated, right? Variables are separated. You can keep 2, 1 by 2 here also, no problem, right? Okay. Now we have to integrate. So integration of 2 divided by, if we take v common, we will have v into 1 minus v, right? Sorry. If we take v common, we will have v into 1 minus, yes, v into 1 minus is equal to minus dx by x. So let's call this as IEC. Let us call this as I, and it will be minus log x, and we'll add some integration constant log c. Now we need to find the value of I. What is I? I is integration of 2 dv divided by b into 1 minus b. This is a proper rational function, right? Numerator degree is numerator degree is 0, denominator degree is 2, so it is a proper rational function. So that means we need to do partial fraction. So we have 2 divided by b into 1 minus b is equal to a by b plus b by 1 minus b, multiply by b into 1 minus b throughout. We will have 2 is equal to a into 1 minus b plus b into b, right? So put b is equal to 0, that means 2 is equal to a plus 0, right? So that means we will have a to be equal to 2, and if you put b to be equal to 1, we will have 2 is equal to a into 0 plus b into 1. So we will have b to be equal to 1, right? Therefore 2 divided by b into 1 minus b is equal to a by b plus b by 1 minus b. So a is 2, 2 by b is 1. 1 by v. You can check it out. If I cross multiply this 2 minus 2v plus, sorry, b is also 2, right? B is also 2. Sorry, b is also 2. Right? So 2 minus 2v plus 2. Okay. So if I integrate this, so 2 divided by b into 1 minus b dv is equal to integration of 2 by v dv plus integration of 2 divided by 1 minus b dv, right? So a is 2, b is 2. So this will be, if I take 2 outside, this will be 1 by v dv. Take 2 outside, we will have 1 minus v dv. This will be 2 times log v. So here, if I differentiate this, we will have minus 1, right? But minus is missing. So we will write this as, we will multiply and divide by minus 1. So this will be 2 times log v minus 2 times log 1 minus v. Right? Minus 2 times log 1 minus v. This is the integral value. So substitute in star. What is star? Star is the required solution. I is equal to minus log x log c. So I is 2 times log v minus 2 times log 1 minus v is equal to minus log x plus log c. Replace y is equal, sorry, replace v is equal to y by x. Replace v is equal to y by x. This will be 2 times log v by 1 minus v. It will be minus log a by log b. It will be log c by x. You can simplify whatever you want, right? It will be log c by x. This I can write this as log v into 1 minus v whole square. This log will get cancelled. So we will have v by 1 minus v whole square is equal to cx, right? Now replace v is equal to y by x is the required solution. Right, a very simple problem. So you just have to check whether dy by dx is equal to f1 of x comma y by f2 of x comma y, and you see whether both are homogeneous functions of same degree. If yes, you can make use of substitution, put y is equal to bx, and then go for it, right? So move on to 11th problem. Sorry, 12th problem. So solve dy by dx solve 1 plus e power x by y dx plus e power x by y to 1 minus x by y dy is equal to 0. So 1 plus e power x by y dx plus e power x by, okay. Do this problem later. Want to, we'll do this problem in the last, right? Want to last. So solve x into cos y by x plus y into sin y by x to y plus y into sin y by x minus x into cos y by x to x to dy by dx is equal to 0. Right? So what we'll do is we will write dy by dx equal to f1 of x comma y by f2 of x comma y. So we will have x into cos y by x plus y into sin y by x to y is equal to, let us take this term that side, y into sin y by x minus x into cos y by x into dy by dx. That means dy by dx is you bring this entire term to the downside. So we will have dy by dx is equal to x into cos y by x, y into sin y by x to y divided by y into sin y by x minus x into cos by x into x, right? So if you put x is equal to tx, y to be equal to ty, both will be homogeneous function of same degree, right? Will be of degree 2, I think, right? Tx will be of degree 2. So call this as 1. Both are homogeneous functions of same degree. That means put y is equal to vx and differentiate with respect to x. That means we will have dy by dx is equal to v plus x into dv by dx. Substitute y and dy by dx value in equation number 1. Right? So what is dy by dx? This b plus x into dv by dx equal to x into cos y by x. So y is vx plus y sin y by x into y. So y is vx divided by, here we have y, right? Wherever you have y, just replace by vx, sin vx x minus x into cos vx by x into x, right? So I can see this x, right? X will get cancelled. If I take common outside, this x will get cancelled, this x will get cancelled, and these x will get cancelled. So we will have v plus x into dv by dx is equal to, here we will have cos v, and here we will have v sin v, cos v plus v into sin v into v divided by, here we will have v into sin v minus cos v, right? So we will have v plus x into dv by dx is equal to cos v plus v sin v into v divided by v sin v minus cos v. So we'll simplify this. So we will have x into dv by dx is equal to, let us take this v to that side. So if I multiply this v here, we will have v cos v plus v square sin v divided by v sin v minus cos v minus v, right? I'm just taking this v to that side. If I simplify this, we will have v cos v plus v square sin v minus v square sin v minus v cos v minus cos v. Yes, so v sin v minus cos v cos v plus v square plus v divided by v into sin v minus cos v. So if I simplify this, we will have 2v cos v divided by v into sin b minus cos b. Here we will have x into dv by dx, right? So I'll separate dv and dx to one side. We will have b sin b minus cos b. We will have b sin b minus cos b divided by b cos b dv is equal to minus plus 2x by 2 dx by x, right? So 2 dx by x. So just variables are separated. Variables are separated. So integrate this. So if I integrate this, we will have to integrate this. So I can write this separately. B sin b b cos b dv minus cos b by b cos b dv. This will be 2 log x, and we will add some integration constant c or log c, right? This is integration of tan b dv will be log v, right? 1 by v. This is 2 log x c. Integration of tan b is minus log cos b. You can see f of b, f dash of b, but minus is missing. So minus log cos b minus log v is equal to 2 log x plus c. So replace b is equal to y by x. It's a required solution. It's a very simple problem. Don't get worried about by seeing the question itself, right? Just follow the procedure. You will get the answer. On to problem. Problem number 13. So solve x into dy by dx minus y equal to x into root of x square plus y square, right? Yeah, x into dy by dx is equal to y plus x into root of x square plus y square. So we have dy by dx is equal to y plus x into root of x square plus y square divided by x, right? Y plus x. So both are homogeneous function of degree 1, right? All this as 1. Both numerator and denominator are homogeneous functions of degree 1, right? We put x is equal to tx, here we will have t f of x comma y, and if we put x is equal to tx, y is equal to ty, we will have both will be homogeneous function of degree 1. So put y is equal to bx, differentiate with respect to x. So we will have dy by dx is equal to b plus x into dv by dx. Substitute y and dy by dx value in 1. We have dy by dx is equal to y plus x into root of x square plus y square by x. What is dy by dx? It is b plus x into dv by dx. So y is bx into root of square b square x square divided by x. This x will get cancelled, right? Is bx. We will have y plus actually here 1x will remain, right? x will remain, because if I take this x square here, 1x will remain, right? This will be dx plus x square into root of 1 plus b square by x. Because if I take x outside, we will have x square here. And here we will have b plus x into dv by dx. So 1x will get cancelled. So we will have b plus x into dv by dx is equal to b plus x into root of 1 plus b square by 1, right? B and b will get cancelled. Now x into dv by dx is equal to x into root of 1 plus b square. And this x will get cancelled, right? So we will have dv divided by root of 1 plus b square is equal to dx. Integrate this. This is what? Log of, and this log of b plus root of 1 plus b square. Or you can also write hyperbolic inverse, sin h inverse of b. Here, dx, the required solution. Replace b is equal to y x. On to 14th problem. Solve dy by dx plus x square dy square divided by dx square plus y square is equal to 0, right? Again, you can see both numerator and denominator are homogeneous functions of same degree, right? So we have dy by dx equal to minus of x square plus 3y square divided by dx square plus y square. So both are homogeneous functions of same degree, of degree 2, right? Both here and denominator are homogeneous function of degree 2, right? So we put x equal to tx, y is equal to ty, we have f of tx comma ty is equal to t power n f of x comma y, here n is 2. So put y is equal to vx, therefore dy by dx will be v plus x into dv by dx. Substitute x and dy by dx value in 1, right? So what is dy by dx? So it is v plus x into dv by dx. Let us keep this term itself, right? I don't want minus here. Plus, what is x square? It will be x square 3 times y square. So y square is b square x square divided by 3x square plus y square, which is b square x square is equal to 0. X square will get cancelled. Now b plus x into dv by dx. This will be 1 plus 3v square divided by b plus b square is equal to 0. So what about simplification of these two? So v plus 1 plus 3v square divided by 3 plus v square, right, is equal to minus x into dv by dx. If we cross multiply this, we will have 3v square plus 1 plus 3v square divided by 3 plus v square is equal to minus x into dv by dx. What about this term? 1 plus 3v square plus 3v plus b, 3v plus b cube, 3v plus b cube. So what about this term? 1 plus 3v b cube plus 3v square plus 3v plus 1 divided by b square 3 is equal to minus x into dv by dx. What about this term? This is nothing but b plus 1 whole cube, right? A plus b whole cube formula. Write this as b plus 1 whole cube divided by square plus 3 is equal to minus x into dv by dx. So we'll separate b's and dv's to one side, x and dx to other side. So b square, so we will have b square plus 3 dv divided by b plus 1 whole cube is equal to minus dx by, right? So variables are separated. Variables are separated. So integrate this. So integration of b square plus 3 divided by b plus 1 whole cube dv is equal to minus log x. So we will add some constant c, right? Now call this integral as I. This is a required solution, but we need to find the value of I. What is I? Integration of b square plus 3 divided by b plus 1 whole cube dv, right? B plus 1 whole cube dv. I'm going to make a substitution. Put b plus 1 to be equal to t, right? Put b plus 1 to be equal to t. Now what about differentiate with respect to t? That means this will be dv by dt plus 0 is equal to 1 plus dv is equal to dt. That means this will be, and if b plus 1 is t, b will be t minus 1. So b square will be t minus 1 whole square plus 3 divided by b plus 1 is t, t cube, and dv is dt, right? And dv is dt. So we have this will be integration of, so a minus b whole square formula, a square minus 2ab plus b square plus 3 divided by t cube dt. This will be integration of t square minus 2t plus 4 divided by t cube dt. Separate this, divide this individually. This will be integration of t square t cube. It will be 1 by t dt. It will be 2 by t square, right? 2 by t square dt. This will be 4 by t cube dt. Integration of 1 by t is log t. The integration of t power minus t. Integration of t power minus t dt will be log t, will be t power is 2 plus 1 by 2 plus 1 plus 4 times t power t plus will be log t. Minus minus will get cancelled, so we will have plus 2 into 1 by t. Here we will have minus 2, right? Minus 2, 2. 2 2s are, so we will have minus 2 to 1 by t square. So replace what we have assumed t is v plus 1, right? Log of v plus 1, 2 by v plus 1, 2 times 1 by v plus 1 whole square. So this is the value of I, right? This is the value of I. Substitute in star. Substitute in star. What is star? I is equal to minus log x plus c, right? Is log v plus 1, 2 by v plus 1, 2 by v plus 1 whole square equal to minus log b. Replace b is equal to y by x. It's a very simple problem. See, we are strong in integration. These are very easy problem, right? On to next problem. To solve, execute minus 3x square dx is equal to y cube minus 3x square y dy, right? So we have dy by dx is equal to, so dy by dx. We have y dy by dx. X cube minus 3xy square divided by y cube minus 3x square y, and both are homogeneous functions. Both numerator, denominator are homogeneous function of degree 3, right? You put x is equal to tx, y is equal to ty, you will have t power 3 f of x, come out. So put y is equal to vx, differentiate with respect to x. So we have dy by dx is equal to b plus x into dv by dx. Substitute y and dy by dx value in 1. Dy by dx is equal to x cube minus 3x y square divided by y cube minus 3x square y. So dy by dx is b plus x into dv by dx, x cube minus 3x y square. So y square is b square x square y cube, 3b cube x cube, 3x square dx, right? X cube, x cube, x cube, right? All will get cancelled. So we will have b plus x into dv by dx is equal to 1 minus 3b square divided by b cube minus 3b, right? We have b minus 1 minus 3b square by b cube minus 3b is equal to minus x into dv by dx, right? I'm just taking this term that side, that term this side. Cross multiply this, we will have b power 4 minus 3b square minus 1 plus 3b square divided by b cube minus 3b minus x into dv by dx, right? These two terms will get cancelled. Now b power 4 minus 1 divided by b power 4 minus 1 divided by b cube minus 3b, right? B cube dv is equal to minus x into dv by dx. Now I'll separate dv's. So dv, b cube minus 3b divided by b power 4 minus 1 is equal to minus dx by x, or If I take this minus outside, I can cancel this minus and this. You will have b cube minus 3b divided by 1 minus b power 4, right? It's equal to dx by x. So variables are separated. Variables are separated. So we'll integrate this, right? So how you will integrate b cube minus 3b divided by 1 minus b power 4 db is equal to integration of dx by x. Let's call this as I. This log x, so we'll add some constant c. Now, how you will integrate b cube minus 3b by 1 minus b power 4, right? B cube minus 3b divided by 1 minus b power 4. Okay, so we integrate this. What is I? I is integration of b cube minus 3b divided by 1 minus b power 4 dv. So let us write this as b cube divided by 1 minus b power 4 dv 3 times integration of b divided by 1 minus b power 4, right? Integration of 3b divided by 1 minus b power 4 dv. This is easy, right? B cube, f of v, f dash of v. If we differentiate, it has to be 4v cube, but 4 is missing here. Let's multiply and divide by 4. Okay, minus 4 is missing, right? Okay. Let's multiply and divide by minus 4. And then let's call this as b. Let us keep this as it is, right? This is log of 1 b power 4. Now we will integrate b by 1 minus b power 4. Actually, this is a partial. You have to do by type 3 partial fraction, but you can do very easily by substituting a variable, right? Okay. So put t is okay. Wait a minute. Put for this, what I'm going to do is put v square is equal to t, or put c is equal to v square. Put t is equal to v square, that we will have dt to be equal to 2v dv. Okay. What we can do is, let us multiply and divide by 2, right? Just multiplying dividing by 2. Let's keep this as it is. 4. This is what? 2v dv is dt, and this will be 1 minus t square, right? Because v square is t, so v power 4 will be t square. So what about this term? 1 by a square minus x square. 1 by a square minus x square. What about this term? 1 by a log minus b power 4 t by 2 to 1 by 2 log 1 plus t by 1 minus. This is the formula for 1 by a square, sorry, 1 by a square minus x square, right? That I already mentioned. That's it, right? So we take this minus 1 by 4 outside, so minus 1 by 4 minus 4 log of 1 b power 4 plus 3 times log 3 plus t to be equal to v square. This is the value of star. Substitute in star. Substitute in star. So t is equal to log x plus t. Replace b to be equal to y by x. The required solution. Move on to 16th problem. solve x square 2xy minus y square dx plus y square 2xy minus x square dy is equal to 0. Right? So we'll solve this problem now. So you can see both are homogeneous functions of degree 2, right? This f1 and f2. So we can do this directly. So we have dy by dx solution. So we have x square plus 2xy minus y square dx is equal to minus of y square 2xy minus x square dy. So we have dy by dx, right? So dy by dx equal to minus of x square plus 2xy minus y square divided by y square 2xy minus or dy by dx plus x square 2xy minus square divided by y square plus 2x. So you can see both are homogeneous functions of both numerator and denominator are homogeneous function of degree 2, right? Both are homogeneous function of degree 2. So put x is equal put y is equal to vx, right? Put y is equal to vx, differentiate with respect to x. So we have dy by dx equal to v plus x into dv by dx. Substitute y and dy by dx value 1. We have dy by dx plus x square 2xy minus y square divided by y square 2xy minus x square is equal to. What is dy by dx? It is d plus x into dv by dx plus x square 2xy minus y square divided by y square plus 2xy minus x square is equal to 0. So x square, x square all will get cancelled. So we will have v plus x into dv by dx plus, so here we will have 1 plus 2v minus v square divided by v square plus 2v minus 1 is equal to 0. It will be v plus 1 plus 2v minus v square divided by v square plus 2v minus 2 minus x into dv by dx. Simplify this, so this will be v cube plus 2v square minus v plus 1 plus 2v minus divided by v square 2v minus equal to minus x into dv by dx. Let us try to group the term. So v square, so 2v square minus v square is plus v square. V cube plus v square, 2v minus v is plus v, this plus 1 divided by v square plus 2v minus plus 2v plus minus x into dv by dx. Now let us try to factorize this, right? So you can see minus 1 is a root. So minus 1 is a root, right? 1, 1. So if I put minus 1, so 0, minus 0. 1. So you can see minus 1 is a root for this cubic equation. This x square plus 0x plus 1. That means this can be written as b plus 1 into b square plus 1 divided by b square plus 2b minus 1. Just factorizing it, that's it, right? Minus 1 is a root means x, b minus 1 is a root means b plus 1 is a factor. This one factor, which is b square plus constant term 1. So we will separate b's and dv's to one side, x and dx to other side. So we will have this to be equal to b square plus 2b minus 1 divided by b plus 1 into b square minus is equal to minus dx by x. Variables are separated. Right? Variables are separated. Now we have to integrate this. Integration of b square plus 2b minus divided by b plus 1 into b square minus b. Integration of dx by x. Let's call this as b is equal to minus log x plus. Right, now to integrate this is a partial fraction of type 3, right? So in partial fraction we will have type 1, type 2, type 3. So type 1, here we will have non-repeated distinct roots, right? This distinct roots. In type 2 we will have equal roots. In type 3 is b square minus b square plus. In type 3 we will have complex roots, right? Square plus. So to perform this, to find I, partial fraction are just 12 standard, 12 standard. How you write this as partial fraction? B square plus 2v 1 divided by b plus 1 into v square plus 1. Now a by b plus 1 plus bv plus c divided by v square plus 1. Whenever you have square inside this, you need to write like this, right? So a by b plus 1, bv plus b by b square. That's it, right? Suppose this is type 3 partial fraction. Type 1 you know, right? If it is distinct means a by b by c by you will write. For example, if you have type 2 means, suppose if you have like this, b square plus 2b, let's write like this, right? B minus 1, b plus 1 into b plus 1 whole square. This will be a type 2 partial fraction, right? If you have whole square, that means here you will have, let's call this as b minus 1, right? How you will write this as a by b plus b by v minus 1, c by v minus 1 whole square. This is how to write type 2 partial fraction. This is type 3. That's it, right? So there are only 3 types. First is non-repeated. That means here you don't have powers here. You just write a by v plus 1, b by v minus 1. We have whole square here, a by v plus 1, b by v minus 1, c by v minus 1 whole square. This is type 2. So type 3, b square will be inside complex roots, right? How you would write? You have to write like this, right? This is type 2. Right? Okay, so we have to find the values of a, b, c now. This way I can write this as a by b plus 1. This is a 11th standard problem, right? 11th, 12th standard. bv by b square plus c by b square plus multiply by b plus 1 into b square plus 1 throughout. So we will have b square plus 2b minus 1 to a into b square plus 1 b into b square plus 1 will get cancelled, b into b plus 1. This b square plus 1 will get cancelled. So we need to find the value of ABC now. So put b is equal to minus 1. If you put b is equal to minus 1, so here you will have 1. Here we will have minus 2 minus 1, right? 2 equal to a into So minus 1 square plus 1. So this will be 2, will be 0. This will be 0, right? Minus 1 plus 1, minus 1 get cancelled. Yeah, minus 2 is equal to 2a. Implies the value of a is minus 1. Value of a is minus 1. Now we need to find other two values b and c. Right? For that, what we can do is you just equate the coefficient of b square. Right? Equating the coefficient of b square. So here b square coefficient is 1. Here b square coefficient is a. After you multiply a inside, here it will be bv square. Means it will be b. Right? So ab square. Here we will have bb square, and here we will have bv something, but we are only equating coefficient of b square. So here you will have a. Here you will have b. So a plus b is 1, and we already know a is minus 1. That means b is 2. Right? Now you put b to be equal to 0. Right? Put b to be equal to 0, or you can also equate constant term also. Right? If you put b to be equal to 0, you will have 0, 0, minus 1 is equal to, if you put b to be equal to 0, we will have a 0 plus 1. So a, and here we will have 0b, right? Because 0 into something, and we have c. That means a plus c is minus 1. We know a is minus 1 plus c is equal to minus 1. That means we will have c to be equal to 0. Right? 1 plus 1. Okay. So therefore, this b square plus 2b minus 1 divided by b plus 1 into b square plus 1 can be written as a by b plus 1 plus bv by b square plus 1 plus c by b square plus 1. To the values of a, b, c now. So a is minus 1, minus 1 by b plus 1, b is 2, 2b by b square 1, and c is 0. So I'm just writing like that. Okay. So integrate this. Integration of b square plus 2b minus 1 divided by dv is equal to minus integration of plus b dv, integration of 2b by b square plus b. This what? Log 1 plus b. This log b square plus 1. That's it, right? This is the integral value of star. Substitute in star. I is equal to what? Star, right? Minus log x plus c. I value is minus log 1 plus b log b square plus 1 to minus log x plus c. So replace b is equal to y by x. It's the required solution. If you want, you can also write like log a minus log b is log a b. Log of b square plus 1 by 1 plus b. You can also write this as log cx. Log will get cancelled, right? You can also do like that. On to next problem. Solve a cube minus 2yx square dx 2xy square x cube dy equal to 0. Separate the variable, right? So we have y cube minus 2yx square dx equal to minus half 2xy square minus x cube dy. So we have dy by dx is equal, or I can write this as dy by dx plus y cube by x square divided by 2xy square minus cube is equal to 0. So both are homogeneous function of degree 2. Put y is equal to bx. Dy by dx is b plus x into dv by dt. Substitute y and dy by dx value in 1. So we have dy by dx plus y cube minus 2yx square divided by 2xy square minus x cube is equal to 0. Dy by dx is b plus x into dv by dx. Y cube will be b cube x cube x square divided by 2x square x square b cube x cube. X cube, x cube, x cube, x cube will get cancelled. So we will have b plus x into dv by dx plus, so here you will have b cube minus 2v, b cube minus 2v divided by 2v square minus b cube. Right, 2v square minus b cube equal to 0. B plus b cube minus b divided by 2v square minus b cube is equal to minus x into dv by dx. With cross multiply this, we have 2v cube minus b power 4 plus b cube minus 2v divided by 2v square minus b cube is equal to minus x into dv by dx. Right? B square. Yes, sorry. Actually, you don't have b cube, right? Because we are just replacing y to be equal to bx. B 1 will be 2v square minus 1. So cross multiply this, so we will have 2v cube plus v cube minus 2v divided by 2v square minus 1. 2v cube plus v cube is 3v cube. 3v divided by 2v square minus 1 minus x into dv by dx. Separate the variable, you will have 2v square 1 divided by 3v cube minus 3v dv is equal to dx. Variables are separated. Now you have to integrate this. Integrate this. This will be, let's call this as I minus log x plus c. Now to find the value of I is integration of 2v square 1 divided by 3v cube minus dv dv, right? Let's do partial fraction here. 2v square minus 1 by 3v cube minus 2v square minus, if I take 3v outside, now v square minus 1, 2v square minus 5. So I can write this as b plus 1 into v minus 1. plus 1 into v minus. This is a type 1 partial fraction. So this can be written as, let's take this 1 by 3 outside, 2v square minus by b into v plus 1 b minus, right? This will be by 3 a by v plus b by b plus 1 plus c by b minus 1, right? So multiply throughout by b into v plus 1 b minus 1, we will have, let's call this as some double star, call it double star. Let's find the value of 2v square minus divided by b minus. After that, we'll multiply 1 by 3 throughout. So multiply by this term, we will have 2v square minus equal to a into v plus 1 b 1, b into v minus 1, c into b into v plus 1. So put b is equal to 0. So we will have minus 1 is equal to, so these two will be 0. We have minus a, right? 0 plus 1, 0 minus 1. That means a will be equal to 1. Put b is equal to 1. Now if you put b is equal to 1, we will have 1 is equal to e into 2. That means c is 1 by 2. We put b to be equal to minus 1. So we will have 1 is equal to e to minus 1, 1. That means minus 1 minus 1. Again b is 1 by 2. Right? So b is 1 by 2, c is 1 by 2, a is 1, is 1 by 2, c is 1 by 2, a is 1. V square minus v. Take 3v common, we will have. So we have a to be equal to 1, b to be equal to, put b to be equal to 1, this will be 0 is equal to 2. Okay, do this. Therefore, one by 3 into 2v square minus 1 divided by b into b plus 1 v minus will be 1 by 3 a by b plus b by b plus 1 c by b minus 1. 1 by 3 a is 1 by b, b is 1 by 2, right? So 1 by 2 to 1 by b plus 1 by 2 into 1 by b. Integrate this by 3 2v square minus divided by b into v plus 1 v minus 1 by 3. This is integration. This is what? Log b. And this is log b plus 1. This is log b minus. This is the value of star. This is the value of star. The of star is what? Integration of 2v square minus 1 by 3v cube minus, right? That is same as I. So I value is this. Substitute in star. It's the required solution, right? You can do this. I think I have completed almost many problems on homogeneous differential equation. I'll just show you one more problem. This a very slow problem right in the beginning. We'll do that problem and then we will wind off homogeneous differential equations. To 18th problem. I'll just show the solution. I'm not going to do that. 18th is the last problem on homogeneous differential. To solve 1 plus e power x by y dx plus e power x by y minus x by y dy is equal to 0. So for this problem, usually we will put y to be equal to vx, right? Put y to be equal to vx and then you will solve. For this problem, we're going to do put x is equal to vy, right? So that right? Usually we will put y to be equal to vx, right? So usually what we will do is we will put what? Put y is equal to vx and so on, right? So since we have x by y, x by y, x by y, so what they are doing is put x is equal to vy. This is the another substitution they are making, right? So that problem will be easy for you, right? Put x is equal to vy. Usually we will put y to be equal to vx, right? So here we are writing x is equal to vy, no problem, right? Okay. Usually we will put y by x to be equal to v, and then we will put y to be equal to v to be equal to v to be equal y to be equal to vx, right? But here they are using x to be equal to vy. Now differentiate with respect to y, right? That means dx by dy is equal to v plus 1 plus y into dv by dy. Now usually you have to do this for the same step. Substitute the value of um, dy and substitute the value of dx by dy and x value in equation number. So first you write dx by dy is equal to like this, right? Just simplify this and then you bring dx to one side, dy to one side and write like this. After that you replace dx by dy as v plus y into dv by dy, and wherever you have x by y, you can write that as v, right? Or is equal to vy. So we'll end up with, after separating the variable, we'll end up with 1 plus e power v divided by v plus e power v dv is equal to minus dy by y. Since we have x by y, x by y, x by y, you make use of substitution. X is equal to vy and differentiate with respect to y. That's it. Right? The only thing is this. And you just bring dx by dy is equal to something. Usually you will write dy by dx is equal to f1 of x comma y by f2 of x. Right? If you are substituting x is equal to vy, you write dx by dy is equal to some function of right? And if you integrate this, this is very easy, right? So f of v, f dash of v. So this is nothing but log of v plus e power v. This minus log y plus log c. Very simple problem. So whenever you see x by y, x by y, x by y, you make use of x is equal to vy. Then you differentiate with respect to y. Usually we will separate dy by dx equal to something, but here you will put dx by dy is equal to something and replace, substitute that dx by dy value and x is equal to vy value. You will get the answer very easy. Okay, that's it. So we will start homogeneous differential equation. If you want some practice problem, I can give you some practice problem also in Telegram group. So in a homogeneous differential equation, I have solved almost 18 problems. I'll give you some 6 to 7 practice problems based on homogeneous differential equation. So you can go through that. The next class, we will be starting equation reducible to homogeneous differential equation. Right? So far, we have completed variable separable method and equations reducible to the form in which the variables are separated. After that, in third is homogeneous differential equation. That also we have completed. Right? So the fourth method is equation reducible to homogeneous differential equation that we will start in the next class. Right? So if you have any doubt, you can ask. Any doubt? Okay, so no doubt. So if you want the PDF on this session, you can download in Telegram group. Description, I have given you the link for Telegram group. You can get that PDF, right? Okay, so thank you. All the best. And one more thing is, we will start uploading the recorded session on modern algebra previous year's questions. Right? So I have already completed I have already solved many previous year's questions on real analysis and calculus. You can go through that playlist. Now I will start modern algebra previous year's question also. I have completed modern algebra content, right? If you go through the playlist, you can see modern algebra new. There is one playlist called modern algebra new, that there will be some 30 to 30 videos, around 30 videos. If you go through the 30 videos, you will be knowing the concepts that is in the syllabus. After seeing those videos in the playlist, see the previous year solutions on modern algebra that I will start uploading soon. Right? We will start with 2022 question paper and then we will go 2021, 2019 and on in the backward, right? In the backward. After that, we will solve complex analysis previous year's question. If you haven't downloaded our app, download our app. This again, the link is in the description. Right? Thank you all best.